Hey, what's up, guys? This is Chung here again. So this time, LeetCode number 932, beautiful array. Okay, so this one is like a medium problem, but this one is very tricky, you know, to come up with a solution. So let's take a look at the description here. So you're given like just a one number n here, right? And then it defines like a beautiful. A is a beautiful, if it's a permutation of the integer 1 to n such that, for every I, j, whereas I is smaller than j, there's no k in the middle such that, ak times 2 equals to ai plus aj. Right? Given n return any beautiful array, it is guaranteed that one exists, right? So here are some examples, right? I mean, we have four. So one of the possible beautiful arrays is 2, 1, 4, 3. So what does this one mean, right? I mean, it means that, for permutation, we have 1, 1, 2, 3, 4, 5, 6, right? So for example, if we have this one here, right? Obviously, this one is not like like a beautiful one because, for example, we have 4, right? So for 4, we have 3 plus 5 equals to 2 times 4. That's why this one is not a beautiful one. Similarly, for 3, right? For 3, we have 1, 5, right? So 2 times 3 equals to 1, 5. That's why, they're like this one is definitely not beautiful one. For this kind of like construction problem, there are usually kind of like two approaches, Maybe the first approach is what? First approach is we have n uh, array, and then from n array we'll try to get n plus 1, right? This is like kind of like a iterative like solution. But can we do that, right? I mean, maybe you can try it, So for example, if we have so let's take a look at this one. So for example, if we have 2, 1, 4, and 3, right? So this is n equals to 4, right? So when n is equal to 5, right? Can we get another one based on this one? I mean, if we add 5 to the end, what's going to happen, right? So we'll have like 3, right? So 2 times 3 equals to 1, 5, which is not right. So if we add it to the beginning, similarly, right? We have we'll have like 4. 2 times 4 equals to 5 plus 3, right? So this is also not correct. So I mean, so this one probably is not gonna be a very good option. I mean, another way, we for this kind of constructive problem, we can always use like divide and conquer idea here, where we can split this array into two parts, which is the left part and the right part, right? So if we can find a pattern of left and right part, we can just do a recursion, right? By just keep splitting the current array into two halves, right? But how should we split, right? That's the problem. So coming back to this kind of like property, we have 2 times ak, right, equals to ai, right, plus aj, right? We want to break this equation, right? And how can we break it? So notice that, on the left side, this is always even, right? Because 2 times the number is always an even number. And I and j, so I is on the left of this AK, right? So this is I, and this is j. And in the middle, we have what? We have even number. So if we can make sure this AI is odd, and this AJ is even, so odd plus even equals to what? Equals to odd, right? And odd will never be able to equal to even number, right? So now we have a approach, right? As long as we can just split the current array into two halves, where the left side is always odd and the right side is always even, right? And then we can make sure, right? That's it's a valid one, but we cannot simply split it once. And why is that? Because let's say we have still, right? So we have 1, 2, 3, 4, 5, 6, right? I mean, we can split it. So we have 1, 3, 5 on the left side, and then we have 2, 4, 6 on the right side, right? Yeah, I mean, this one, the whole one is on the left side is odd, and right side is even. But if you look it closely, this one is it's not a beautiful array, because 3, it's in the middle of 1, 1, 5, right? That's why this one should be like actually 1, 1, 3, 1, 1, 5, 3, and this one should be like 2, 2, 6, 2, 6, 4. So this one is kind of like like recursive call, But how can we accomplish this one, right? And so I'll give you an example here. We can start from the smallest beautiful array, and then we can just go from there. So what is the smallest beautiful array? 1, 3, 2, right? This one is easy to get, right? So from this 1, 3, 2, how can we get a bigger number? Oh, sorry, like a bigger array, right? We can get, this one is 3, right? So if we can get all the odd number from this one and odd even number based on this one, we can always we can also construct like a longer number, And the reason being is that there are like some properties for this kind of equation here, you know. So first, right? I mean, if you multiply 2 on both sides, okay, this equation, the result of this equation, either is not is the inequality of this equation stays the same, right? And if you do a plus or minus on both sides, this equation or the non-equation also holds. That's why from this 1, 3, 2, what we can do is that if we do a 2 times each number and then a minus 1, this will give us odd number, right? We're in the array who has the double size. And if we do a 2 times I here, this will give us all the even number. And why is that? Because okay, so if we do apply this formula to each of the number here, so what will we get? We get 1, 5, and 3, right? How about the second one? 2, 6, 4, right? Since we have this kind of property, what does this one mean? It means that after applying these two formula, the beautiful array, the result is also a beautiful array, because by doing this 2 times multiplication and do this minus, this inequality still holds, right? So that's why we have now we have 2 beautiful array, right? And if we concatenate those 2 beautiful array together, we get a new beautiful array plus 2, 6, 4. Okay, so first, since we are following this kind of formula, these 2 smaller array, they're both beautiful array, right? Because we have already proved that. But why, if we concatenate them together, it's also a beautiful array? This is because the left side, since we apply this formula on our original one, the left side they're all odd numbers, and the right side they're all even number, right? So going back to this kind of property, since we have odd numbers on the left and an even number on the right, so AI plus AJ will always be a what? An odd number, right? And this left side is always even. Now it comes back to this formula. That's how we basically we divide this this big array into a smaller one. And if we every time we apply this kind of formula, right, on each part, and after that we concatenate, because we're guaranteed each part is a beautiful array. And after applying this one, the new array is also a beautiful array. All right. So with that being said, let me try to code these things here. So for that, to solve that, we need a helper functions. It's n here. So and we return the helper of n, right? So if n is equal to 1, right, we return what? We return 1, because that's going to be the base case, right? Otherwise, we have odds equals helper of n divided by 2, right? And then we have evens equals helper equals to n divided by 2. Okay, and then we do a return, right? We concatenate those together. For odds number here, we 2 times x minus 1 for x in odds, and then plus what? Plus the even one, right? So for the even one, we do the same for x in evens. So that's the way we do it. But there are like few things I also want to explain here. So first, this one, it's odd and even. Sometimes n is an odd number. Let's say n is 5. So what does it mean? It means that the even one, the odd one should be should have one more number, because we're doing this kind of like flooring thing. That's why we have to do this kind of plus n, do a modular by 2. So this one means that if n is an even number, we'll have like a bigger number in the odds helper function, which is a 3 here and 2 here. Okay. And about this part, odds and even. So why we're doing this way? Okay, so let's say we have n is equal to 6. Okay, so what do we have? We have like helper 3 and helper 3 here, right? Both of them are 3, and both of them will return what? Both of them will return like a 1, 3, 2, right? That's going to be the smallest number here. And since we have this 1, 3, 2 and 1, 3, 2, if we apply the same thing on this one by doing the different formulas, we'll get what we were just saw, right? We'll have like 1, 5, 3 plus 2, 6, 4, right? That's how we use this kind of recursions, and we divided this array into a smaller one to get a bigger one. And also, and if n is equal to 5, right? So which means that we will have like what? We will not have 6, right? Which means that we have one 153 plus 24 in this case, right? And then that's why we'll have like two in this case, right? So and we have 3 and we have 2. So this 3 will give us a 132, right? And then this 2 will give us what? This 2 will give us 1 and 2, right? That's why in the end, same thing for this. For 132 we have 153, and then for the even one, we instead of 264 we'll have 1 2 and 4, right? So this one is also like a beautiful one, beautiful array. Yeah, I mean, I think that's the basic idea, right? I mean, okay, if I okay, let me try to run this code here. Okay, we have this one 1324, right? So submit. Yeah, so it works, right? I mean, the time complexity for this one, we every time we divide it into 2, right? And for each of the recursion, we'll like do a linear thing here. So it should be n log n in this case, right? Yeah, I mean that's it, right? So that's the basic idea here. I will talk about another like even trickier solutions after this one, but they're using the same concept, which is the by dividing the same group, like the bigger group into 2 parts recursively, where left side is like odd number and the right side is even number, right? And after dividing those 2 parts, so the way we're generating this one is like, we're for the left side and and the right side, assuming they have the same numbers, right? Like I said, because the smallest beautiful is 132, right? So in order to, you can think it this way. So in order to concatenate to make like a bigger number from this one, we'll have like another 132 on the right side, right? Which is the odd and even, right? But how can we get the but this one is 3, right? What we need is 6. How can we get the numbers from 1 to 6, right? That's why we apply this current formula, this formula on the left side and this formula on the right side. And like I said, since both left side and right side, they are like beautiful array, by applying this kind of linear like formula, it's still gonna be a beautiful array, right? That's why this one becomes a 153, this one becomes a 264, right? And if we concatenate them together, odd, even, right? Still a beautiful array. Okay, so that's going to be the first one. And the second one, right? So there's like a second solution, which requires you to convert this n into its binary, the numbers into its binary form, and then we just sort by the binary form, by the binary string. And why is that? So let's say we have 0, 0, 1, right? And 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and yeah, something like this. So we have 1. So this is 1, 2, 3, 4, 5, and 6, right? So like what we just discussed, we want to move all the numbers. We want to move the odd numbers on the left side. Okay. So at the beginning, what are the odd numbers? So 1, 3, and 5. Right. So what is in common? So they have um, 1 as their first, the least significant bit, right? If you take a look at the value of the bit values, so 1, 3, 5, they all have 1 on the least significant value, right? Where the 0 are the remainings are the even numbers. That's why, you know, if we sort this by this first by this left by the rightmost bit, we'll get 135 and then 246, right? But if this bit is the same, then what do we sort? We sort by the by by the by the second one, which is this one, which is 0, right? Oh, sorry. I think if we sort, I'm sorry. So if we sort by this one, you know, we'll have like since 0 is smaller than 1, you know, if we sort by this bit, we'll have like a odd even number on the left side and the odd number on the right side. You know, it doesn't really matter, right? As long as we can split those numbers into two parts, so it doesn't really matter. We have even number on the left side, or we have odd number on the left side. The results are the same. Okay. So if we sort by the by the least significant number here, bits here, we'll have like odd even number on the left side, and odd number on the right side. But within this kind of like even number and odd numbers, you know, like I said, we have 2, 4, 6, and then 1, 1, 3, 5, right? We cannot use the same order here. You know, instead we should have 2, 6, 4, and then 1, 1, 5, 3, right? So this is the final answer. And if we take closely at this bit string here, you know, so we have let's say for odd number 0, 0, 1, 0, 1, 1, and 1, 0, 1, right? So after sort, if the same, if the first bits are the same, and then we compare with the second least significant value, which is this one, and what do we have? We have 0, 1, and 0. If we sort this one, then what we have? So which means 5 will come before 3, because 0 is smaller than 1. That's why we will have like 1, 5, and 3, right? Similar for this kind of 2, 2, 4, 6. We have, after do the sorting, we have 2, 6, 4. So the pattern basically is we simply just need to sort each number from 1 to n by the reversed reverse value of the bit string, because since we want to sort since the first value we want to sort is the least significant one, right? Okay, so how can we implement that, you know, in the code, right? I mean, in Python, you know, we can do something like this, you know, we can convert them into a we can have like a list, you know, like the numbers. It's going to be a list of what, of the range 1 to n plus 1, right? That's the odd numbers, and then we do a sort, right? So nums dot sort key is going to be a lambda, right? Of x, we need to convert this string, each number into a string, and then we reverse that string, right? We can do like like a bin of x, you know, but this bin of x has this kind of 0x or 0b something. I think 0b 0100, which means the first two letters should be ignored, right? And we also want to reverse this one. So what we can do something like this, right? We can do this one. You know, the last one is what? The last one is a -1. We all know this one is like a reversing order, you know. But after doing this reversing order, if we only want to get starting from the second one, we should do a 1 here, right? That's how this Python slicing in Python means. If we don't do a reverse, right, and we want to do like starting from the second one, we do a 2. This is how we do the want to do the starting from the third one, right? We do a 2 colon. But if we want to do this one plus a reversing order. Since we're doing this kind of minus one, that's why we're gonna do a 1 here instead of 2, because we're starting from the end, right? Yep, I think that's all we need. You know, we get like a array here, and then we sort by this reverse binary string here, and then we'll get what we want. You know, we simply return the nums here. Run the code. Let's see. So we have 4, 2, 1, 3. You know, if we have like a bigger number, let's say the 6, right? So we have 4, 2, 6, and then 1, 1, 5, 3, right? Oh, I think I made a mistake. Should be 4 to 6 instead of 2, 2, 6, 4, right? So if we do an 8 here, you know, right? Similarly, we have the same value here, same result, right? So the even number is on the left side, and right, and the odd number is on the right side. Yeah. So for this one, and as you guys can see, this one is like, I think it's also unlog n, right? Because we have a sort, right? We sort these n numbers by some like lambda function here. Yep, I think that's pretty much I want to talk about for this problem. Yeah, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.